right. Hey, this is Matt Does Math. I was asked by a student the other day about circumference of circles and tires, and so I decided to come out here today and do a big long bike ride. And what I want to do today is I want to get back to Asheville from Madison County and Marshall's courthouse here, and I want to find out how many times these wheels go around all the way back into Asheville. So we're going to do some calculations and we're going to do some riding. It's going to be a great day. We're about halfway back into Asheville right now. We're following along the French Broad River. It's a beautiful fall day, about 70 degrees, and look at those wheels turn. Turning, turning, turning. Let's count them up. Let's see how many times.
Simple. How many times do those wheels go around? So as I came back into town, I said, you know what? Let's go ahead and get on Google and let's see if we can map it out. So that's what I've got in here. I started at this great bike shop right there in Asheville, and then we rode all the way to Madison County Courthouse. And as I go ahead and Google this information, it's going to say 17.1 miles there. But guess what? We're tougher than that. If you look over here on the left, you're going to see this road 251. That's actually what we did. We went ahead and followed the river all the way out, so we need to make sure that we show that. We had 18.8 miles from Madison County back in Asheville. We actually did that twice.
Riding in Western North Carolina is a pretty daggone good time, especially in the fall when it's gorgeous like this, but it's not all easy. Sometimes you got to go uphill, and in these mountains, they get steep, real steep. I'm thinking there's got to be an easier way to do this problem. Maybe there is.
Hey guys, I'm here in my secret math lab garage, and I took the wheel off the bike, and I'm trying to catch a little bit of information so I can solve that problem about how many times this rotated from Marshall all the way into Asheville. So I think what I'm going to do is I'm going to take that measurement, I'm going to measure it all the way down to the center. I'm going to find the radius of this here wheel, and then we'll start with some more calculations. So just looking at it right here, I know y'all can't see it, I'm looking at 12.5 inches. I hope that gives us enough information to solve this problem.
We made it back into town. That was a long ride, and I got to give it out to this bike shop. They helped us out in the beginning. Had a couple flats. They took care of it for us. A great shop.
Break it down. Let's solve this problem. Problem was, how many times will my bike wheels rotate from Marshall to Asheville? And over on the left-hand side of the screen, you're going to see, hey, I've got the wheel with a radius of 12.5 inches and took what we researched on Google, which was the distance from Marshall to Asheville to be 18.8 miles. Now let's go to that wheel real quick and let's break that down, because it tells us what the radius is, and there's really only two things we could do. We could either find the area, which is really the space within that circle, or we can think about the circumference, and that circumference is representing the distance around that wheel. So I'm thinking in this case, since we're talking about distance in miles from one city to the next, and we're talking about the wheel going around, we're going to have to talk about the circumference of this wheel. So let's go ahead and start by saying, hey, circumference equals to what? 2 times pi times r. And let's fill that information in. I said, well, 2 times pi times a radius of 12.5 inches. And we could write that this is 25 pi inches. And for approximation purposes, we can say, okay, well, I know 25 pi inches is approximately 78.5 inches in length. But now we get into some really weird information, because we are measuring with inches, and over here we have miles. So is there somewhere in the middle we might be able to meet? I'm thinking so. I know that 1 mile, let's say that 1 mile is 5,280 feet. So maybe we can convert that mile to feet. And then if we think about it, well, I can take 78.5 inches and convert that to feet. And let's do that. I'm going to take 78.5 inches, convert it to feet. How do I do that? I divide by 12 inches. And when I divide by 12 inches, that gives me 6.54 feet. And let's go ahead and tell what that means. That's per rotation. And we know 1 mile is 5,280 feet. So nice, we've already converted to our measurement that we can use in all of our calculations. So let's think about what else we're gonna do with this. I know from Marshall to Asheville, every single time 6.54 shows up, that means that we have 1 full rotation. And this happens over and over and over again, all the way until we get to Asheville. And we need to count how many 6.54s there are in the 18.8 miles. Well, let's find out how many rotations there are in 1 mile. Well, how do we do that? We divide. Nice and easy math there. So I'm going to take 5,280 feet, and I'm going to divide it by 6.54 feet, which is right here, right there. And what does that give me when I make that division? It's going to tell us that we have 807.3 rotations per mile. So that wheel goes around 807.3 times in 1 mile. Well, we didn't go 1 mile, we went 18.8 miles. So what are we gonna do? For the first mile, it went 807. For the second time, it went 807. For the third time, it went 807. For the fourth and the fifth, it just kept going 807. Well, we keep repeating that addition, we can multiply. So let's go ahead and multiply 18.8 miles. And then we can say, okay, 18.8 miles times 807.3 rotations per mile. What? So we were able to say, okay, well, those cancel, those cancels. And what are we left with? We are left with a total of 15,177.24 rotations. And that's our total rotations from Marshall Courthouse all the way into Asheville. That's a substantial amount of rotations. And if we wanted to account for both ways, we just double it. What a great problem. Super stoked to get that done. That was a lot of fun. And hopefully we'll see some more cool problems like this again.